So owing our tribute to Einstein, I would like to explain his concepts first, and then we'll move towards the concepts of space, right? So first, these are the confusing topics most of the time students do not understand, and that is the reason I've taken this. That is general theory of relativity of Einstein and specific theory of relativity of Einstein. So we'll look at one after the other. So what does general theory of relativity talk about? It talks about two things. Okay, it basically talks about gravity, right? So how gravity affects time and space. Okay, to explain it in a much simpler manner, I'll tell you. This theory says that gravity impacts the space. Okay, gravity tends to form a curvature in around. Okay, so form a curvature around it. So consider this rubber sheet. Okay, on this you drop two masses. Okay, you take two masses, one is bigger one, other is a smaller one. When you drop them, what happens? This will make a curvature around it. Okay, so you see the shape formed, and this smaller mass also tries to make a curvature around it. But with the movement of the larger mass, this smaller mass also tries to move around it because of the impact created by the greater mass. So now you have to understand one thing. When you drop a mass onto a rubber sheet, what happens? It forms a curvature around it. So gravity, just like that example that we are discussing, okay, just like the example we are discussing in a similar manner, it happens at the large scale as well. Okay, now just imagine they are the two planets. So the masses consist of gravity, and this gravity tends to form curvature around them. Okay, so gravity as a curvature of space is the first concept it tries to say. And second thing is that time is not same everywhere. Okay, so it says that time can stretch, time can stretch as well as shrink. So what does this mean? Now suppose if you are closer to a planet, okay, so if you're on a planet which is having very high amount of gravity, so in that case your time ticks very slowly. Okay, so now you are on a planet which is 10 times the mass of the earth, so its gravity is going to be 10 times, right? Its gravity is going to be 10 times. So now since the gravity is very high, and now this is gravity of the earth, this is gravity of the other place, right? Now here if you look at 1 minute is equal to 60 seconds. Okay, so here this 60 seconds might be 1 millisecond only. Okay, so here 60 seconds have been passed, but here only 1 millisecond has been passed. Here it's 1 year, here it might be only 1 day. Okay, so that means time is not constant. It can stretch, it can shrink based on the gravity. Higher the gravity, slower the time. Lower the gravity, faster the time. Okay, so this thing you need to understand. Time is inversely proportional to gravity. Okay, so higher the gravity, you have less time. Okay, so lesser the gravity, you have fast time. Okay, so this is the speed of the time. So speed of the time and gravity relation. So time can stretch as well as shrink, and gravity can form a curvature around it. So this is about the general theory of relativity. So now we'll be seeing the specific theory of relativity. So what does it talk about actually? So have you ever heard of this thing? So what is general theory and the specific theory or the special theory? So specific theory or the special theory of relativity. What does it talk about? First thing, it says that speed of the light is constant. Okay, suppose there are two people, one who is standing and other person who is traveling on the road just beside him on a car, okay, at 150 kilometers per hour. Okay, he is a standstill. Now this has got headlights and it is emitting the light, right? So now this light speed is same for both of these people, irrespective of however fast you are traveling. So first thing is that speed of the light is same to everyone, always the speed of light is same, no matter how fast you are traveling. So these things you need to keep in mind, that in general theory of relativity, we have talked about two things: how gravity is affecting space as a curvature, and time. Okay, so how time is not constant throughout. It depends on the gravity. So coming to specific theory, you have speed of the light, and the speed of the light is always constant. And it talks about two more things, that is time dilation and length contraction. So what do you understand by time dilation? Specific theory of relativity says that time can move differently for different people depending on how fast they are moving. Okay, so suppose if you are zooming around in a spaceship, okay, if you're zooming around in a spaceship at a speed of light, you are going at a speed of light. Okay, so that is c. You are traveling at a speed of light, and time would pass slower for you. Okay, if you're traveling fastly, time will go slowly, and those who are traveling slower, for them who are standing still, the time would pass fastly. So this is what it's trying to say. So it might sound strange, but this has been proven in case of atomic clocks. If you have studied regarding atomic clocks, we'll also be discussing about the newly launched navic. Okay, so Indian navigational satellites. There we have tried to repair one of our atomic clocks. So atomic clocks are nothing but these clocks are made up of very sensitive elements, okay, which can recognize even the minute changes. Okay, so they can track even the microseconds, right? So one of the atomic clocks have got repaired, and we have tried to replace it with a newer version, and we have been successful in replacing it. So you need to understand one thing, that first light speed is constant for everyone, and next there is time dilation. That means time can move differently for different people. For some people who are moving fastly, it is going slow, and for some people who are going slow, time is moving fast. So this might sound strange, however, it has been already been proven, right, in case of atomic clocks. And next is length contraction. So time dilation means time is not constant for all. Somebody who's moving fastly, they see the time is ticking slowly, and somebody who's going slowly, they see time ticking faster. So this difference is there, and that is called as time dilation. And